Hello everyone. Today I am going to tell how to find the domain and range of these functions. Before going to tell that, I just explain what are domain and range. For example, if you take any function like f of x is equal to x plus 1, here the set of all the real numbers which satisfy this function is called the domain. So here, for example, if x is equal to 0, then y is equal to 0 plus 1, that is 1. If you see like this, x is equal to 1, x is equal to minus 1. So here you are giving all the x values as real numbers. So these are the real numbers. We know that real numbers are rational numbers as well as irrational numbers. So if you put some x values like this, then you will get some y values. Y is equal to f of x. So you will get some y values. If you observe here, x values are 0, 1, minus 1, minus 3 by 2, then root 2. You will get some y values as 1, 2, 0, minus 1 by 2, root 2 plus 1. Here root 2, x is equal to root 2. So here y value is root 2 plus 1. So here these input values, the set of all input values is called domain, and the set of all output values. So these are the output values. 1, 2, 0, minus 1 by 2, root 2 plus 1. These are the output values. So here this set is called range. And if you write the domain of this function as, see here you can write any real number in this domain. So that is, you cannot write all the real numbers in a set, so that you can show like capital R. So this is set of all real numbers. Capital R means that is set of all real numbers. Or you can show this in an interval notation like this, open bracket minus infinity to infinity and close bracket. And here range of f is equal to, here range is also, if you observe all these values, range is also all real numbers only. So that is also R, or you can write minus infinity to infinity. So this is the range of this function. So you can write domain of function, this function is R, range of this function is also R. Because here input values are also real numbers as well as the output values are also real numbers. So here in this function, if you give any real number as input, that is domain, you will get a real number only as an output, that is range. So here range and domain are real numbers only. So if y is equal to f of x, here x is input and this is range. Y values are, that is range. The set of all y values are, that is range. And the set of all x values, that is domain. And the domain you can easily identify because you can easily understand what x values you can give in this function. But it is difficult to find the range values because every time it is a small function. If you take any big function, then it is difficult to apply the x values and you have to identify what are the y values. So every time it is difficult to find the like that. The range is difficult to find like that. So you have to write x in terms of y. For example, here the function is y is equal to x plus 1. So here this is domain. Domain can be any real number. You can directly identify here. But for range, you have to write x is equal to y minus 1. Here x is equal to y minus 1. So you have to write x in terms of y. Then identify the y, how the y values are. From this function, you can identify how the y values are. From this, you can easily understand the y values are also the real numbers. Because here the function is simple function, x is equal to y minus 1. So you can, here if you see here, x values you can give any real number. Here also y values, any real number, the output can be any real number. So easily you can identify like this. If you do some problems, then you will easily understand how to find domain and range of these functions. This first problem, if f of x is equal to x squared, if you see this function, here you can give any real number as x here. So here directly you can write the domain of this function is equal to capital R. This is a set of all real numbers because here you can give any real numbers. Then you will get the solution. Or you can write in an interval notation like this. And you can check if x is equal to -1. If you give x as some real numbers, then you will get some solutions like this. Y is equal to 1, x is equal to 0, y is equal to 0, x is equal to 1, y is equal to 1, x is equal to -√2, then y is equal to 4. So if you observe these values, here x can be any real number, but y is only 0 or positive number. So here all y values are non-negative real numbers or are plus. Non-negative real numbers means including 0, all positive real numbers. So here the range is non-negative real numbers or R plus. You can calculate like this, but it is every time it is difficult to apply like this, and you have to understand what the y values are, because it is a small function you can find, but you have to find the range like this. Just y is equal to x square right here. And I told you just now, you have to write x in terms of y. So x is equal to, here y is equal to x square. Therefore, x is equal to plus or minus square root of y. From this function, you have to check how the y values are. Because y is in the square root, it should not be negative. It can be 0, but it should not be negative. So y is greater than or equal to 0. So you have to check like this. The range you have to check like this. So because the y is in the square root, it should be greater than or equal to 0. That means it is 0 or greater than 0. So positive numbers, 0 are positive numbers. So non-negative real numbers. Therefore, range of this function is equal to r plus, or you can write in an interval notation like this, 0, comma, infinity. Because including 0, so you have to put this bracket. And this is open bracket because infinity is a symbol. It is not a number. So you have to exclude always infinity like this. This is second function. F of x is equal to x minus 2 by 3 minus x. In this case, here the x is in the numerator and x is in the denominator also. So like these cases, you have to check both numerator and denominator also. First check the numerator. In the numerator, it is a simple expression x minus 2. So in the numerator, x can be any real number. You can put any real number here. So here x, the domain is any real number, but you have to check denominator case also. In the denominator, we know that it should not be 0 because 1 by 0 is undefined. So it should not be 0. So here x should not be 3 minus x is not equal to 0. This expression should not be 0. It is not equal to 0. Therefore, x is not equal to 3. Because if you apply 3 value here, then 3 minus 3, that will become 0. So in the denominator, it is 0. So it is not defined. So x should not be 3. Therefore, domain of this function is equal to r minus 3. Except 3, all other remaining real numbers is the set of all the remaining numbers is the domain of this function. So because here this is set and this is also this 3 element also you have to put in this braces, because this is set, this is also a set. And to find range, I told you, you have to write x in terms of y. So first write y is equal to x minus 2 by 3 minus x. So to write x in terms of y, you have to cross multiply here. So y into 3 minus x, that is 3y minus xy is equal to x minus 2 into 1, that is x minus 2. So write all the y values at one side. 3y plus 2 is equal to x. Here minus xy becomes plus xy. Then 3y plus 2 is equal to x is common. So x into 1 plus y. Then see here x you can write in terms of y. Therefore x is equal to 3y plus 2 by 1 plus y. Here also numerator y is in the numerator and denominator also. So you have to check both the cases. It is in the numerator, so you can give any real number. And here it is in the denominator, it should not be 0. So 1 plus y is not equal to 0. Therefore, y is not equal to minus 1. So except minus 1, you have to take all the real numbers, remaining real numbers. That set is the range of this function. Therefore, this you can write as r minus 1. You have to eliminate minus 1 here. Like this, you have to find the range of these functions. This is another function. f of x is equal to 1 by 1 minus x square. So here you have to check here the domain values. Here it is in the denominator, so it should not be equal to 0. 1 minus x square is not equal to 0. Therefore, x square is not equal to 1. Therefore, x is not equal to square root of 1, that is plus or minus 1. So, except plus 1 and minus 1, all the remaining real numbers are the domain of the function. So, domain of this function is r minus except these two values plus 1 and minus 1. So minus 1 comma 1. This is the domain of this function. And to find range, you have to write y is equal to 1 by 1 minus x square. Then cross multiply here, y into 1 minus x square is equal to 1. Then y minus y x square is equal to 1. Then y minus 1 is equal to y x square. Then x square is equal to y minus 1 by y. To find range, you have to write x in terms of y. So x is equal to plus or minus square root of y minus 1 by y. So here you have to check y is in the numerator and in the denominator, and also it is in the square root. So you have to check these cases. So first check y is in the numerator. So y minus 1 is greater than or equal to 0, because in the square root it can be 0 but it should not be a negative number. So y minus 1 is greater than or equal to 0. This is first case, and it is in the denominator, so it is not equal to 0. So y is not equal to 0, and you have to check y can be less than 0, because y is in the numerator and denominator. If you apply any negative value, then it is also in the denominator, so then it will become positive. You can see with this example here, for example, y is equal to minus 1. Then square root of minus 1 by minus 1. So minus 2 by minus 1. Cancel minus minus, then it will become a positive number, square root of 2. So you can check y is less than 0 also. So for the first case, y minus 1 is greater than or equal to 0. Therefore, y is greater than or equal to 1. You can see on the number line here, it is y is greater than or equal to 1 here. That is 1 to infinity. So it includes 1 also. And in the second case, y is not equal to 0. So y is not equal to 0. And then y is less than 0. So y is less than 0 means this case. So for example, you just apply y is less than 0, any less than 0 value, that is minus 1, it will become positive. So here also it is valid, minus infinity to 0. So you can not to 0, it is excluding. So you have to write minus infinity comma 0. It is excluding. 0 is excluding because y is not equal to 0. And these two cases are valid. You have to check from 0 to 1 numbers. For example, if you take any number between 0 to 1, that is 0.5, if you apply that value, 0.5 minus 1, that is less than 1. So it is negative. By 0.5, it is positive. So in the square root, it should not be negative. So it is not defined. So if you apply any values from 0 to 1, then that is not defined. This function is not defined. So you have to take only these values and these values. So the range of this function is equal to minus infinity comma 0 union 1 comma infinity. Here 1 is including, so you have to put this bracket. Remaining all are excluding. So you have to put these brackets. This is another important problem. F of x is equal to x by 1 plus x square. So here x is in the numerator as well as in the denominator also. So here you have to check in the numerator first. So here x you can apply any real number. So here x belongs to capital R, and in the denominator case it should not be equal to 0. Therefore 1 plus x square is not equal to 0. Therefore x square is not equal to minus 1. We know that any square number never be a negative number. So here x can be any real number, because if you apply any negative number, minus 2 whole square, that is 4, again positive number, and it is never be 0. So here x can be any real number. Therefore domain of this function is equal to R. And to find range, you have to write x in terms of y. So y is equal to x by 1 plus x square. Cross multiply here, y into 1 plus x square is equal to x, then y plus yx square is equal to x, then yx square minus x plus y is equal to 0. This is in the form of a quadratic equation ax square plus bx plus c is equal to 0. So the roots of this function, the roots of this equation, quadratic equation, x are minus b plus or minus square root of b square minus 4ac by 2a. So here a is equal to y, b is equal to minus 1, c is equal to y. So you have to apply all these values here to find the roots, that is x. X is equal to here minus b. So minus of minus 1, that is 1, plus or minus square root of b square. So minus 1 whole square, that is 1, minus 4ac. 4 into y, that is 4y square by 2a. So 2 into y. So these are the roots of the function x is equal to this one. And here y is in the numerator and y is the denominator also. So you have to check both these cases. So first take here, this is in the square root. So it is greater than or equal to 0. And it is in the denominator. So it is not equal to 0. So first case 1 minus 4y square is greater than or equal to 0. Therefore 1 is greater than or equal to 4y square, or 4y square is less than or equal to 1. Therefore, y square is less than or equal to 1 by 4. Y is less than or equal to square root of 1 by 4, that is plus or minus 1 by 2. Therefore, y is less than or equal to minus 1 by 2, or y is less than or equal to 1 by 2. So you have to check again these two cases. So generally, if any x or y is less than or equal to like this minus 1 or plus 1 or minus 1 by 2 or plus 1 by 2, then the range or domain will be from minus 1 by 2 to 1 by 2. Or you can check with this example. For example, you see on the number line, here less than or equal to 1 by 2. So less than or equal to 1 by 2 means from here. And minus 1 by 2, less than or equal to minus 1 by 2 means from here. So you have to check both the cases. First, you can take any number less than minus 1 by 2. For example, minus 1. If you apply minus 1, then square root of 1 minus 4y square. Y is minus 1 whole square. Then that is minus 4. So this is equal to square root of minus 3. So negative number in the square root is not defined. It is not defined. So you should not take any numbers less than minus 1 by 2. It can be minus 1 by 2, but less than minus 1 by 2, you cannot take. So you have to take all the numbers from minus 1 by 2 to 1 by 2. So here the range is minus 1 by 2 to 1 by 2. So you have to show in these brackets. But again, one more case, to y is not equal to 0. Here in between 0 is there. So you have to check again whether y is not equal to 0 or y is equal to 0. So for that, you have to take that function first. See the function. This is the given function, y is equal to x by 1 plus x square. So here you have to check whether y can be 0 or not. Yes, because if you apply x as 0, then you will get 0 by 1, that is 0. So y can be 0. But here y is not equal to 0 is not correct in this case. So y can be 0. The solutions, in that solutions, y can be 0. So the range of this function is minus 1 by 2 to 1 by 2. This is another type of problem. F of x is equal to 1 by square root of x minus 5. It is a square root function. So here it is in the denominator, it is not equal to 0, and it is in the square root, so it is always positive number. So it is greater than 0. Therefore, x minus 5 is greater than 0. Therefore, x is greater than 5. So here we should not take 5 and greater than 5 values only you have to take. If you apply 5, then 5 minus 5, that is 0. So 1 by 0 is undefined. So domain of this function is equal to, you are excluding 5. So put this bracket open interval, comma, infinity, because all positive numbers only. And to find range, you have to write x in terms of y. Y is equal to 1 by square root of x minus 5. Then on squaring both sides, y square is equal to 1 by x minus 5. Then x minus 5 is equal to 1 by y square. Therefore, x is equal to 1 by y square plus 5. If you see here, y is in the denominator, so it is not equal to 0. And here, if you see the function, it is in the square root. All the square root numbers are positive only. So the solutions of this, if you see here, the solutions of this function are always positive only because it is in the square root. So you will get the solutions always positive. So it is greater than 0 also. Y is a solution, so output. So y is always greater than 0. You can see this note, the solution of any square root function is always positive. Therefore, range of this function is you are excluding 0 also. So because here y is not equal to 0 means you are not getting in this solution 0 value. And you are getting all positive values only. So that is this meaning. So you have to write that range is 0, infinity. You are excluding 0 here. Now practice these questions. Here these two functions are square functions. So you have these solutions are always positive only. The range is always positive only. You have to apply the. And here are the answers.